what differs, right? Okay. If you have any question, you can ask me. Now, whenever you do implantology, you place the implant, and the next stage is the loading, correct? Your implant failure is usually at the 3 stages. One, at the time of surgery, because of some infection control, you do some really blunder there. Your osteotomy is wrong, clear? And then within a week or 10 days, you find out if there is an infection, correct? If your infection protocol is not correct, then you have an early failure, right? But the late failures, usually, which are more troublesome and very painful, are when you load the implant with the prosthesis and implant fails. Clear? And that usually happens maybe after, say, 4 months in the case of mandible, because at the end of 3 months you start fabricating. It takes almost a week or 10 days or 1 month for hybrid prosthesis, and for a maxilla maybe after 6 to 8 months. Clear? And by then the patient's expectation is also very high that my implant is already osseointegrated, and you make it and it goes for the failure. Correct? So what is the reason for behind this? Is the occlusion overload. Occlusion overload, or there can be a faulty occlusal scheme. Clear? So implantology does not end by placing the implant. It is the end result which leads to the failure. And I hope you know it, because it is a dynamic kind of contact you make with your teeth. That's called as articulation. Right? Okay. So the long-term success will be only with the mechanical force, how much force is falling on the tooth. That is the implant. Okay? Okay. If you have any question, you can stop me and you can ask me. Because try to understand and learn it by interaction rather than passively listening. Right? Humanly not possible. Therefore, in 1 hour 45 minutes, I can do justice with the whole subject. So, how active you are, that is how you will learn maximum. Right? Okay. These are some of the photographs which show the failures when the patient is given the prosthesis. It may range from a ceramic fracture, it may be a crestal bone loss, it may be screw loosening, it may be a framework failure. Right? So it can be anything. Okay. Now, the major difference between a natural tooth versus a implant. Most important thing is the periodontal ligament is not there. So if it is not there, the proprioception is not there. One thing. Secondly, the periodontal ligament gives you a kind of leverage or leeway for some movement. Clear? Whether it is in the vertical direction or it is in the lateral direction. So, and it also acts as a, whenever we are talking about the forces, it acts as a resilient tissue. As a resilient tissue. So it has the ability to absorb a lot of force without transmitting it directly on the bone. Whereas the implant is ankylosed. It's kind of ankylosis. You have osseointegrations directly, there's no periodontal ligament. So whatever the force is falling on the prosthesis to the implant is directly transmitted over the bone. Clear? Anything which is not clear on the table, please ask. And the range of movement you must be clear. The vertical range of movement of a natural tooth is from 0 to 5 microns, whereas an implant we talk in terms of 25 to 30 microns. Clear? Lateral is almost double. From 50 it goes to nearly 100 in case of natural tooth. Clear? Right? What difference does it make if I don't have a periodontal ligament? I have told you no proprioception. Also, I have said no resilient tissue. Then what difference it makes? No shock absorbers. What else? Good. How much is the thickness of periodontal ligament? How much thickness of periodontal ligament in a natural tooth? Perio? Penis? Point? 1 mm. Perio, who is from Perio? How much is it? 0.8. That will be 0.8 to 1 mm, it will be called as periodontal writing we see on IOPX. Clear? Clear? So that is the. So what effect it makes? What difference it makes? If I say there is a shock absorber or there is a resilient tissue in between the implant and the bone, forces are distributed better. Do you understand a word called impact? What is it? Sudden transfer of forces. Yes. So this is nothing but we talk in physics is the rate of change of momentum. Rate of change of momentum. Yes. Anything which strikes you suddenly, there is no time gap. Suddenly hits you very hard. Yes. So the impact forces will be very high. The impact of the forces will be very high. That is very detrimental to the bone. Clear? Okay. Anything else in this slide? Clear? Can I change? Okay. There is another major difference between the implant and the natural teeth. What's the widest diameter of implant you can ever use? Normally? 5 millimeter. Correct? And you try to place a crown over a 5 millimeter implant. And the molar has got 3 loops. Correct? How much is the diameter of that? Cross-section diameter. They are elliptical. Obviously, they are not round or circular. They will be around 2.53 millimeter minimum, but they are elliptical. Is it good or bad if I have an elliptical? It is always good. Fine. See the beauty of the nature. Nature has provided you in the molar 3 roots. So the pericemental area will be much higher versus your 5 millimeter implant. Secondly, they are divergent most of the time. Correct? So if you have a stool which is have a divergent or a broad legs, you will be more stable or less stable. Right? So forces will be always falling based on the root. So it is almost criminal to remove a healthy tooth and place an implant. Because biomechanically it's going to fail, it is not going to match your natural dentition in any way. Clear? In a molar, if you think your implant will survive for a lifetime, it's a little difficult. If your roots are fine, periodontically they are sound, try to salvage it as much as possible. Clear? And the reason is very clear. Because you have the proprioception. Why I am talking again and again of proprioception, I just discussed. Secondly, it also gives you a shock absorber. Impact is less and they are divergent. Pericemental area is much more. Clear? Clear? Any question? Change? You have any question? Okay. These are 2 words we are very much familiar, occlusion versus articulation. Occlusion is a static relationship between the maxillary and the mandibular teeth. And the articulation, we say, is a dynamic concept where the relationship of maxillary or mandibular teeth in each and every position, right from your centric intercostal position to any excursive position, whether it is protrusive or laminar. Right? Yeah? And that is where the difference comes between you talk about the occlusion, orthodontist talks about the static occlusion. You must have studied the classification where you have the molar relation, and in a prosthetics we don't talk about that static occlusion because the patient has the freedom to talk, to chew in probably any possible way. Correct? Chewing cycle doesn't follow the static rules. And the forces fall in a dynamic manner. Correct? Correct? And whenever we talk about the mechanical forces, these dynamic forces are very difficult to manage. And that's the root cause of failure, because whenever you start your practice, the success for the patient for implantology is not any other parameter of bone loss or anything. He only wants how many years my implant or the prosthesis will last. Clear? And the failure, root cause will be your uncontrolled or detrimental forces over the implant. occlusion, I hope you know. There is nothing but simultaneously contact of anterior and posterior bilaterally. Okay, lingualized occlusion is nothing but a simple case where the lingual cusp of the molar will be in contact with the almost flat surface of the mandible. Why do we do it? Anyone? It doesn't give you any masticatory efficiency, it is rather causing a lot of loss of efficiency. But why do we give lingualized occlusion? And where do we give it? Correct, wherever the patient has a neuromuscular disturbance, he doesn't have a fine control, because whenever you close your mouth into a intercuspal position, it will have one specific position. But patients suffering from Parkinson's will have difficulty. Right? This is where. Another way we give a lingualized occlusion is in complete tension to increase the stability. Remember, your cusp in a natural dentition, you all have a cuspal teeth. There is a reason behind it. What's the reason? Why you have a cuspal teeth? Why don't you have a flat teeth? You see a lot of animals, carnivores, will have a flat teeth. Why do you have cuspal teeth? Pain? Huh? Better chewing efficiency. Yes, but it has a disadvantage also. What is that? It always creates on an inclined plane a horizontal component of force will come, and that is your biggest enemy, remember, in implantology or any prosthetic work. Your biggest enemy is the horizontal component force, and I'm sure you must have read about it. If you have a missing tooth, the posterior tooth always tries to drift forward. We also call it an anterior component of force. It's nothing but a horizontal component of force, because mandible is not a straight flat bone, it is a inclined plane again. Yeah? Done? Okay. Mutually protected. When anterior will come in contact, posterior will be out of gear, and when the posterior come in contact, the question is why? Why do we need mutually protected articulation? Louder, please. Bruxism. Most of us are not having bruxism. So why do we have mutually protected occlusion? It decreases? It decreases tooth wear. Which tooth? It decreases, correct? Posterior tooth wear. Why? See, as I told you, the forces can fall along the long incisor tooth or can have a horizontal component. So when you bite on the posterior teeth, your anterior are out of gear. Correct? And the masticating forces are where high in the anterior or posterior? Posterior. They will always fall on the axial direction, and anteriors are always proclined. Anteriors are proclined. So if there is a force falling on the procline, every time you bite, the anteriors will fall down. Correct? And when you do any kind of protrusive or lateral protrusive movement, your anterior will come in contact and posterior will be out. And that is when your posterior teeth will not undergo any kind of attrition. Right? Okay. You can ask me anything, you have to be active. Correct? There is no point paying money and sitting like this. Why are you sitting here? Listening to me? No, you must come here to learn. Right? मैं तो बहुत सा चला जाऊंगा, आप कब तक बैठोगे? You have any question you ask? Group function, you know? Do you have group function in your mouth, or you have a canine protected occlusion? Why canine? Why do we need a canine protected? Why do we need canine protected occlusion? No, I don't want to, because we have discussed many times. I want then answer. Because canine has the longest tooth. So crown root ratio will be very favorable. You have a canine buttress, so the bone is very dense there, so it can bear a lot of your horizontal forces. Clear? Right? Then where do we give group functions? Where do we give group functions? No idea. Implantology, forget implantology, you can't even practice fixed partial lecture until you know these facts. Clear? Implantology is not placing an implant in the bone, you have to furnish it. Clear? End result is patient pays you money only for the teeth. He's least bothered whether you do implant buccally, subcostal, supracostal, he is not interested. He is only interested in the end result. Yes? So, where do you give group function? Sorry? If you are ever replacing canine, remember with the implant, never do canine protected occlusion. Correct? Because as I told you, natural teeth has a long root. Your implant will not have one thing. The pericemental area will be long. Proprioception will be there. Resiliency will be there. So don't say because the patient had canine protected occlusion on the opposite side, this side also I am replacing a canine and I am going to give a canine protected occlusion. You will go for a failure. You will go for a failure. Clear? That. Secondly, group function gives me an advantage. Here, masticative forces are generated. That's the patient. They will be distributed. So the pressure over each and every tooth will be reduced. So we get group function. Right? Okay. Okay. These are the principles we want to do. One, we want to make the forces as less as possible on the implant. Reason I told you, because the number of roots are less, pericemental area is less, and resilience is less. Secondly, I also want the forces should be axial. What do you mean by axial? They should be falling along the long axis of the tooth. There should not be any angulated force falling on a implant. Clear? And all interferences, what is interference? Premature contact can be interference, yes. What else? What else? Interferences are usually seen on the non-working side. Whenever you do the lateral excursion, on the non-working side, if there is a contact, it's called as a interference. You move your jaw on one side, the opposite side does the teeth make contact? Do it. You all move to the left side, does the right side teeth make contact? No. So that is a healthy thing. That is what I am trying to teach you here. If there is a contact, that is called interference. Clear? Okay. Any question? Any question, please? No. Okay. So, keeping these things in mind, and these were simple things we were following in case of fixed partial as well. Only thing, wish only combine all of them and gave it a coined the term implant protected occlusion. Nothing else. Because we never wanted, we never needed, because natural teeth had a fair, wider surface area. Correct? But the biomechanics remain the same. Correct? So it's nothing new. Which did, he just clubbed it all together under the term coined as implant protected occlusion. Now, see the irony of the situation. In the natural dentition, we all try to develop a occlusion where maximum masticative forces can be developed and your chewing efficiency increases. Here in the implant, we are trying to reduce the force, thereby protecting the implant. See the major difference. There is a paradigm shift. Have you ever bothered by chewing where my forces are falling? Any one of you? Nature has given you such beautiful roots which will take care. But here, once we start doing the artificial prosthesis, we have to protect the prosthesis itself, the substructure. reach a pinnacle where everything will be taken care of, you're standing still. There will be failures if you do not understand and you think you can do everything. Not possible. Not possible. Clear? So it is, you have to be guarded, and that is where your diagnosis and treatment planning comes into picture. Clear? Okay. See, this is the aim. That's what even Mish says. Aim is, it should be prosthetically driven, and you have to minimize the forces. This is what exactly Mish gave in action. Read it. If anything is not clear, please tell me. So occlusion load or masticative force is the same. Clear? Whenever I say low masticative force, it's a vector quantity, it will have a magnitude as well as direction. Clear? So we'll play with both of them, how to minimize those forces, thus they are no more detrimental to your implant. Clear? Done? So these are the 12 mechanisms by which we can play around while developing the occlusion. Clear? I'll discuss each one of them. Done? Okay. This is what premature occlusal contact, and this is where the role of proprioception comes into play. Whenever you are chewing or you are suppose eating something and suddenly there's a stone, while chewing you have something, what happens? Do you continue chewing or do you suddenly break the chewing cycle? It happens because of the afferent fibers coming from the periodontal ligament. This is what proprioception does. Now, if you have a premature contact because of some faulty processes, what will happen to the patient? Again, the afferent signals will go to the brain, and from there the motor command will come to the muscles of mastication, and it will bypass. It will bypass the interference. That means your closing cycle or closure cycle has changed. Correct? If there is an obstacle on the way, we always take a diversion on the road. Yes? Same thing, the jaw will also take a different path. But this is not possible in case of when you do have a full mouth implant-based prosthesis. There is no proprioception. So if there is any damaging to premature contact, it will remain, and your brain will not realize it. It will keep on hitting it. Clear? So this is what very important thing. And second thing, if there is a minor obstruction, there is a movement, possibility of movement of the periodontal ligament, in which by virtue of which the teeth can slightly shift, act as a shock absorber, yes, and bypass it. So there are two defense mechanisms you have: is a slight movement of the tooth in the bone, and second is your path of closure by the motor neurons. Your masticative muscles will change their path of closure. Clear? But both these things, defense mechanisms, will not be available to you in case of you do an implant. It's the same thing. If anything which is not clear, please ask me. Same thing, what I discussed just now. Can I change? Again, what we discussed, we will try, you always try, whenever you go to your teachers, they always say wider implant. Yes, over a narrow implant. The reason very obvious, I explained you much earlier. Yes, we want maximum perisymmetry, or we want more of osseointegration, so surface area of the bone versus implant. Contact should be, we call it BIC, bone implant contact surface area should be as high as possible. Clear? But no way you can match natural teeth in case of molars. No. Clear? So in case you sometimes bone doesn't permit you, so do we have to place a narrow implant? There, the number of implants should be either increased or you have to splint it with others or reduce the number of the teeth. Clear? It's the same thing, it's all falling in one place, isn't it? Logical. Any questions? Anything which is not clear till now? I'm asking all of you, anything which is not clear? All clear? Okay, this is just a simple diagram. It shows that all forces fall in the 3 dimensions. X, Y, and Z axis. Clear? We'll discuss that. Now, this is very important. Many times we come across conditions. Suppose if I have a chair, you put weight on the chair, anything will happen to the chair? No. But if I try to push this podium from sideways, can I do it? Easily? Same thing, angulated. Either the implant is angulated or the force is angulated. Now this scenario is very common. Can the force be angulated? Can the force be angulated on the toe? Yes. During excursive movement it can be there. Right? And your implant also can be angulated. Because why implant is angulated? For? And they are not prosthetically driven. Because there are 2 ways you can place the implant. One, for the operator, the surgeon's convenience. Wherever he finds the bone, wherever he finds a path of incision easy, initial severity, he will just put it and run away. You start fabricating the prosthesis, you will see the consequences. Second is, you decide the prosthesis first, and based on that prosthesis, you put the implant. Which is better? So it should be always prosthodontically driven. We'll just discuss. Now, in this case, what will happen now? Can you make out? If this slide is not clear, I can make it easy for you. I have done this slide. Is it clear to all of you, or should I make it simple? Or explain it? Nothing is happening. We are doing only vectors, vectorization. How? Just imagine. This is you have a right angle triangle, and draw a straight line that is hypotenuse. So whenever the angle, this is nothing but the anterior component is just sine theta. Sine theta. If there is a board, I can draw. Otherwise, there's a pointer. Yeah. See, if I draw a straight line here, just like this, so there will be an angle here. Yes, and there will be a corresponding angle here out of 180. Yes. So this angle will form sine theta, and sine 30 is how much? Half. So that's what this is showing, is at 30, there is 50 newtons of horizontal force, buckle force falling here. Correct? So whenever you place angulated implant, we normally place angulated implant only in few conditions, only to achieve good aesthetics. We have to do it sometimes. Clear? We have to do it to make a proper, better aesthetics. We do it. But remember, nothing is free. There is a cost. Hidden cost is the horizontal force is increasing, and which can cause failure. So that is why no company makes the implant angulation beyond 30 degrees. That means you are basically putting 50% of your load in the horizontal component. Try to minimize the angulation as minimum as possible, because sine curve goes from 0 to 1. Correct? So 30 gives you half, so you try to make it 10 degrees, 15 degrees, maximum 15, not go beyond that. Do not go beyond that. This is what this slide is signifying. Clear? Right? But it is very simple when you are in the operatory. So wherever you get the bone, you just put it. And come out of it as a champion that I placed the implant. What will happen later? In this college, you will not bear the fruits. But outside, in your practice, wherever you are going visiting will catch you by the collar. Because your money is given to you only when you put a turnkey operation and you give the prosthesis. Correct? And once the first case goes for a failure, he will stop calling you. He will stop calling you for the next case. Clear? So therefore, that's why I'm saying it is prosthetically driven. You have to keep the processes in mind and the longevity of the processes. Nobody spends 50,000 rupees in the clinical practice for a 6 months or 1 year. They want minimum 10 years. Assurance. Yes? So therefore, please avoid angulated implant as far as possible. Go as wide an implant as possible. Multiple implant as possible. And you know, your domains start becoming narrow and narrow. Clear? This curve is showing only one thing because sine theta, sine curve goes as the angulation will increase. At one stage, if it is 90 degrees, it will go almost whole course is horizontal. Although we don't place horizontal implants. But exceeding by 45 degree also is dangerous. Okay. Now, whenever the bone force is falling on the tooth, processes goes to the implant, from implant we go to the transfer to the bone. And bone is an anisotropic material. You understand what is anisotropic? Which does not have the properties same in all directions. And the classical example is you all have seen IOPs or X-rays, you see the trabeculate. What does a trabeculate mean? All of you have seen trabeculate? Yes, it is a pattern. So why is pattern came? Anybody? What does trabeculate mean? What is it? They are nothing but hydroxyapatite crystals. Right? The bone is like a composite which has a matrix, which is organic matter, and it has a filler. Filler gives you strength. So these trabeculae will be directed in such a manner that they are perpendicular to the direction of the force. Perpendicular to the, all of you are sitting on a seat, the seat is perpendicular to your body weight. And that is why you are comfortable. Can you sit on an inclined plane for such a long time? No. Correct? So trabeculae are designed by the nature, evolved by the nature in such a way, wherever the force will come, it will be perpendicular. And that's how the bone develops or achieves its compressive strength. Right? Now, bone is wonderful in the compressive strength. That's how we are all the time in the world. We are walking, running, jumping, because whenever the forces are falling on my legs right now are the compressive in nature, are compressive. Correct? But bone is very poor in tensile and in shear strength. Most of the fracture takes place is because of tensile failure. Same as yours. Or ceramics fail because of tensile strength is poor. Or your dental cements fail because your ceramics fail because bone is also mostly ceramic. Yes? Because organic component is very less. Yeah? So tensile strength is less. This is what this picture is showing, that bone can bear the load more of compressive rather than shear organism. So the objective should be that our implant based occlusion should also give compressive force, and that is only possible if I give an axial force. Yeah? Okay. Yeah. So all angulated forces will create shear load or tensile. So chances of bone loss is there. Okay? Can I change? Yes? Okay. This picture is showing nothing but the first, on the left hand side, force is axial. The other is angular. Again, it will develop all kinds of tensile and shear stresses. Okay? So what happens when you give in? What is the solution then? Either you increase the number of implants or the same thing. Increase the size, number, split them, make the occlusion table narrow. Eliminate the lateral load by giving make the cuspal angulation flat. Okay? This is what I was talking about. Nature gave you a cuspal teeth. Reason why? Chewing efficiency, but it also has a cost. It creates a lot of horizontal forces. Right? Forget whatever you are doing today. You did complete lectures, and that there you studied anatomic teeth at an angle of nearly 30 degrees. Semi-angle nearly 20 degrees at 0 degree. Okay? So, what angle should we give for implant processes? Should it be 30 degrees, 0 degree, or 20 degrees? It should be around 20, less than 30, because we don't want horizontal force. Wherever the inclined plane will come, we will create definitely a horizontal force. Clear? Yeah? And this is very clear. You can see here, these are all functional cusps. In the buccal, the lower mandible, buccal cusp is a functional cusp. In the maxilla, there is a maxillary cusp. So they should fall on the axial line. Then, mutually protected. We have already discussed, because the posterior mandible is a jaw. PMD is a class 3 liver. It's like a nutcracker, isn't it? So you have maximum forces generated between the fulcrum and the forces. So maximum forces will be in the posterior. Yeah. So we always try to give it a mutually protected. So when the posterior are in contact, the forces are tend to be more axial and anterior out of it. Don't get confused by this value of PSI, because this is nothing but force per unit area is a pressure. Okay? So it is only with the surface area you have divided. You are concerned with the force. Now, anterior guidance is very important, because many times you will be replacing the anterior. So your anterior guidance, what you studied is horizontal overjet and vertical overjet. That should be minimal. That should be minimal, so that there is a smooth glide when the patient comes to a protrusion. Otherwise, your lower teeth will tend to hit the upper, and where the horizontal forces will be increased once again on the implant and will go for a failure. Right? But this has a lot of application in your clinical practice, because you are doing, patient is coming only for aesthetics, and the aesthetics is only achieved by developing an optimum amount of overjet and overbite. And when you're doing it, many times your anterior guidance will be steep. And once it becomes steep, there will be a lot of force falling on the implant. You can't give a patient an open bite and say, that, correct? Nobody will buy that process. Right? So, you're understanding, there are a lot of constraints. What looks very rosy, the failure comes because you have to meet the aspirations of the desire of the patient aesthetically, functionally you have to fulfill. While doing it, if you cross the physiological limits, there is bound to be failure over a period of time. Am I clear? So you have to be a little guarded. I'm not scaring you, but you have to be a little watchful. This we have already discussed. This is a class 3 liver. Canine is a very different thing. Whether you're doing a bridge, fixed means whether you're doing a bridge or you're doing the implant. I think you all were interns also part of the CEP this week. And Dr. Sindhi was talking, canine is a relative contraindication. It's not an absolute contraindication by when you're trying to replace a canine with FPD, but it's a relative contraindication. Depends how far it is or what type of arch form you have. If there is a cantilever, if there is it is far away from the interabutment line, it will create a lot of torque. It will create a lot of torque. Okay. This we have discussed, that if you are replacing implant-based canine, never do canine protected occlusion, you always give a group function. Clear? So this is only 2 points which I want to convey. In FPD, be careful, relative contraindication. In plant base, you will develop a group function rather than canine. Okay. This is the same, right? Okay. Cantilevers. I hope you all know cantilever. Where the distalmost or mesialmost tooth is unsupported. Cantilever is never a good thing. It is never a good thing because it develops a lot of torque, right? And the forces on one of the abutment will be always non-axial. Non-axial. So this is nothing but a simple diagram of force into force arm and load into load arm. You can see if I increase the cantilever here with a little force of 50 pounds, I'm getting this force which is like a couple, will be almost double because the distance is half. Right? So principle is try to minimize the cantilever or make it zero. Best is do not give a cantilever on an implant because as I told you, implant's root surface area is much smaller than the natural teeth. We do give cantilever bridges and most of them survive over a period of 5 years. Fine? But never do this mistake on an implant. Reason very obvious, implant root surface area is very small. Clear? Don't say we can give cantilever bridges, why can't we give it here? No, it will not work. Clear? It is not going to work. Okay. Huh? I personally will feel that do not give cantilever. Ground height ratio is again a vertical offset. If your implant interact space is more, correct? So your ground height will be almost 8. Normally, how much is the ground height? I gave you the answer, 7 to 8 mm. But if it's much more than that, please don't do that because there will be a lot of vertical offset and there will be a lot of failures. Right? But opposite is also true. If your interact space is very less, then you do not get good cementation because there has to be minimum height of the abutment. How much is the minimum height of the abutment? 5 mm is the optimum. 5 mm is the optimum. If you have more than that, can create problem during lateral excursion. If it is less than that, it is going to be a failure for cementation. Right? So you must evaluate when doing the diagnosis how much space is for the process. Is there a space or not? I see many times the cases where the abutment, forget there is no place for the abutment. How can you diagnose a case and place the implant just because you have to place the implant? You have to leave some space for the processes as well. And the minimum is 5 mm for the optimum is 5 mm for abutment, and if you give a PFM 1.5, that means 6 to 7 is the minimum requirement of my space between your implant and your opposing tooth. Correct? And if you're giving zirconia, add another 0.5 to 1 mm. Right? But don't go beyond that. If it is more than that, how will you do it? How will you handle it? There can be cases where you have a much more than that. How will you do? Or if it is less than that. If it is less than that, then go and place subcrestal implant. But that is only possible if there is a space in this bone. There is no vital structure. And this is your, what is this? This is working side on movement. This is called as non-working. Remember, non-working will always make more 90-degree angle. Such questions you always get in the national board examination. So this is a working side, this is, sorry, non-working side, this is working side, this is protrusion. Right? Okay. You can read this slide if anything. You can ask me a question. Mostly ideal situation will be, suppose if this is my implant, a process of crown over the implant, my implant should be centered over the central fossa, and my functional cusp of the opposing arch should be coming and falling here. beginning of the motion. This is my centrifugal intercuspal position. From here, I do the protrusive, working, non-working. But what if my opposing force, functional cusp is falling here on the marginal ridge in the intercuspal position? That is creating a horizontal offset. Because forces will, implant is here, the force here. This will create a lot of, again, torque, vertical, horizontal offset. Yeah? And that's why we say it should be processed optically driven. So you design the processes first and then place the, right? So again, saying in the functional cusp, see, remember the cross is indicating your functional cusp is falling exactly under the implant. The force over a wider contact on your